Hello, I'm Tom Hopkins. I'm assistant professor here at Bossier Parish Community College. And today what we're going to do is we're going to talk about an introduction to programming. Not any one particular language, but we're going to look at some general information. We're also going to look at the hardware and the software. We're going to take a look at how the computers store data, but we're not really going to go too much into depth into that, just a touch on it. We're also going to look at how a program actually works between this high-level language all the way down to what the computer can actually understand. Okay, let's take a look at what a computer is. The actual definition, if you will, is a device that can be programmed to accomplish a task. Well, something that's really impacted our civilization, that's such a simple definition. But in reality, the computer is nothing but a machine that does exactly what the programming tells it to do. Nothing more, nothing less. It can't take over your house, can't take over your desk. It just does what it's told to do. Telling it what to do is a program. Now, a program is a set of instructions that a computer follows to perform a task. You see that on the screen. Well, we refer to this as software, but these two go hand in hand, the hardware and the software. And of course, the person that actually does this programming, that writes this beautiful language, they design, create, and they test the program and get it ready for you to use. And that's also, they are called programmers, and they're also called software developers. So what we're going to do is take a look at, let's look at the actual hardware. Now the hardware, you think, oh, I know what a computer is. Well, let's take a look at it. Computer can be anything. It's a physical device devices that make up the computer, and they make up desktops, laptops, tablets, smartphones. But something you may not consider is they also make up your microwave, your air conditioning heating system in your house. They are found inside most kitchen appliances nowadays. They're found in your dryer and your washer. So we've got computers, this hardware, all throughout our house and our home, and they basically help us live a lot more comfortably. Now the typical components that we look at, we're going to look at 4 different areas, because a computer, no matter what it is made up of 4 basic pieces of equipment. The central processing unit, also called a CPU, and the CPU is the brains of the computer. It actually takes the programming, tells the computer what it's supposed to do, and it moves the information through the machine. Now we've also got something, we call it main memory, but you're probably more familiar with it as random access memory, or RAM. The RAM is actually a temporary memory area, and this is where the programming moves pieces of information starting out, and we pull it from the storage device when we first click it to get it started, and it goes into our random access memory, this temporary storage area or temporary memory area. The CPU then uses that to process the instructions, which in programming language is each line is made up of a set of instructions or a particular instruction. Now the storage devices is what allows us to keep all this into one big device. And they can be anything. They can be a mechanical hard drive. They can be a solid state hard drive. We have flash drives. We have old floppy disks. We have compact disc or computer discs, as we call them. You can even have it down to a small SD card that you use in your camera, which actually can be used as a hard drive on some small computers. Along with that, storage devices, all of this would be worthless if we didn't have an input and an output device. Now you're real familiar with them, you use them all the time. but may not think of them as an input and an output. The typical input-output devices are the keyboard and the mouse. Now, the other input, it could be a scribe, it could be this camera that I'm talking to you and the recorder that I'm talking to you with. Those are also input devices. They're inputting it into the computer. The computer is recording all this, putting it into the memory. When I close it out, it will go into a storage device. And then anytime I can call it back, and then we can look at it. Well, from your end, you're looking at an output device. Typical output devices are your monitors in front of you. But we also have an output to a computer, to a printer. And something you may not think about is when we start talking about the thermostat in your house or the buttons on your microwave. The output can actually be start a motor, change a valve, flip a switch. So output can be many, many things besides just what we think of as the monitors, for instance. Okay, the software itself. Now, the software does everything as far as controlling the computer. It's all done with this software, this programming. Now, there are two general categories of application or system. Now, the application software is basically, that's what makes the computer useful. Those are your games, your word processing, your email programs, your web browsers, so you can browse the internet. The system software, on the other hand, is something you don't really see, you don't really think about it. You turn on the computer, on the switch on the computer comes up, and you proceed to log into your computer or your phone or your laptop, whatever device it is. Well, that system software is what actually controls the computer. It controls that CPU. It controls that storage device and the random access memory. So that's your system software. And someone's got to write that programming as well. Now, programming itself is made up of keywords, operators, and then we've got syntax. Now, what is programming? Programming is another language. For me, my primary language is English, so therefore it would be like me learning to write in French. Programming is made up of keywords just like any language in the world. There are predefined words that mean something. They have a very specific meaning. Like in English, we have chair. Chair, if I tell you chair, you know exactly what I'm talking about. Well, the keywords that are found in programming are very similar to that. And we have different keywords such as print. That's across all languages. We have input. In other words, give me something to work with. And those particular words mean something across all languages. We also have operators, and that provides our arithmetic, our mathematics, or mathematical operations on data, for instance. And you're real familiar with this, the plus and the minus, add and subtract. We use a star for multiplication, or an asterisk, and then, of course, a diagonal to the right is a division. But we also have things like greater than and less than, which are comparators. Now, out of all these keywords and the operators and how you write it, we have grammar, just like any other language. Except in programming, we call it syntax. Now, the syntax is the set of rules. It's the grammar. And then, of course, we also have sentences, just like in grammar, just like in languages. We call them statements. And these are the individual instructions, line by line, because a computer reads programming line by line. It doesn't take the whole thing in. It reads it one line at a time into memory. Okay, once we get it in there, how does the computer actually relate to this? Well, the computer has a problem. We write in something that looks more like English than what the computer can understand. The computer can only understand ones and zeros. The switch is on, that's 1, or the switch is off, that's 0. Back when we first started the very first computer in 1937, the computer was made up of actual physical relays, electrical switches. And whether the switch was open or closed determined which pathway that the electrical current followed. Well, it hasn't changed any. We've just miniaturized it all the way down, and we've now got thousands and thousands of those little switches. So something has to change this high-level language that's written in something we can read down to what the machine language that the computer can read, which is made up of nothing but ones and zeros. And we have an intermediate program in the middle of that called assembly language that does this translation. So the compiler translates the high-level language into machine language. And then on top of them, compilers, we also have something we call an interpreter. Now this is a little different. We have languages that are, for instance, web-based languages, JavaScript and HTML. They're a high-level language, but yet we're not going to execute them in the computer itself. We're going to interpret them using another program. And so there's no separate machine language exactly. Now we've got, and you use these all the time. Every time you go into the internet, there is a program written in HTML, probably a JavaScript, and when you open up your browser and go to a particular website, that website then sends back that language, that programming. And your browser then interprets that right there on the screen to show you your web page you want. So all these languages put together, whether it's compiled or interpreted, then becomes our source code. Okay? Okay, in summary, what we've covered is what is programming, what it can do, what it can't do, the main hardware components, the types of software, whether it be application or system. We've talked about what makes up the programming, and of course, being able to compile it down to machine language, which is where the computer actually works it. One question I get from my students is, can I do this? Is it easy? Well, it's not particularly easy any more than learning to write in another language is, but it's not difficult. They also ask, what can we do with it? There are jobs out there. About 1% of the population of the world are programmers, actually a lot less than that. And so therefore, there's a lot of jobs available. They talk about basically needing a lot of programmers in the next 10 years or so. And so the one way to find out if you're going to like it, well, do you like puzzles? Don't know. But if you like to try solving puzzles, failing, and then trying again, programming might be something for you. The only way you're really going to know is to go ahead and try it. So the rest of our segments are going to show you some particular languages. Take a look at it. If nothing else, you'll learn more about the computer. And in any case, have fun with it. Thank you.